Because these CO2 levels are significantly higher than anything we've seen in the last 800,000 years. That should be worrying enough without having to sort of blame every last detail of modern climate change on anthropogenic greenhouse gas emissions. It's more nuanced than that. Hi guys, David here from Almost Daily Science. So today we're going to talk about some new research that just came out about Arctic warming and how this might actually undermine some of the things that we've taken for granted so far in our quest to understand climate change and specifically the human impact on climate change. We're going to talk about what this research is, look at the results for ourselves and try to see if it's legit. And we're also going to talk about what some of these implications might be. So to start off, I want to look at the CNN summary of this article. So the central claim of the article is right up front. It says, the Arctic Ocean has been warming since the onset of the 20th century, or early 1900s, decades earlier than instrument observations would suggest, according to new research. The Arctic Ocean has been warming up for much longer than we previously thought. And this is something that's a bit unsettling, according to the climate researcher, for many reasons, especially because the climate models that we use to cast projections of future climate change do not really simulate these types of changes. In other words, there's forward-looking models that researchers have developed, and that's the basis for our understanding of what's going to happen, say, when the global average temperature rises by a certain amount or CO2 levels rise by a certain amount. We can therefore expect a certain environmental outcome. However, those models are always based on what happened in the past. That's basically how they build them. They say, well, we have these relationships. We understand, for instance, the relationship between CO2 and global temperature to some extent. And so we can say, and how that impacts, for instance, Arctic ice covering. And we can predict, therefore, that if carbon dioxide levels get to a certain point, then we can expect XYZ to happen. However, what they're saying is the picture, especially when it comes to Arctic warming, may be significantly different than what we thought it was. And so, in other words, all of our forward-looking predictions are based on poorly calibrated assumptions. And that may actually completely undermine our models about what's going to happen in the future. So the lead researcher actually said, it's not clear how much of a role, if any, human-caused climate change played in the early Arctic warming, and more research is needed. And that's a really important statement because when it comes to this kind of thing, there's a lack, I would say, of robust scientific discourse being carried out in the public eye. This is a statement that requires a lot of nuance. As I said, it says, it's not clear how much of a role, if any, human-caused climate change played in the early Arctic warming. The article then goes on to say, we're talking about the early 1900s, and by then we've already been supercharging the atmosphere with carbon dioxide. It is possible that the Arctic Ocean is more sensitive to greenhouse gases than we previously thought. However, it's also possible that this early Arctic cooling and significant loss of ice covering that they observed through their tests indirectly has nothing to do with human carbon dioxide emissions. And that's really important because there's a lot at stake here. Now, in my opinion, scientific discourse should be something that is aimed at getting to the bottom of things. It should be aimed at trying to find out what the truth of the matter is. However, when it comes to things like climate change, there's often a sense that we need to do what is expedient, what will cause the most beneficial outcome for everybody. So, for example, there's definitely motivation in the eyes of some people to actually lie about science if it leads to people making, we'll say, good climate choices. And so if the data does not support a particular way of thinking of things, then maybe it's best to just ignore this data. So what I'm curious about is to see if this story will end up getting pushed or promoted. My guess is that there's going to be a lot of people trying to suppress this story because it basically undermines the accepted model of how Arctic warming has been working. The idea is that we have massively increased CO2 emissions, and those massive CO2 emission increases are causing the greenhouse gas effect to accelerate and cause global ice melting. And I'm not saying that's not true. I think that's probably true. But the thing is that the extent of ice melting can probably not be fully attributed to anthropogenic carbon dioxide emissions or man-made carbon dioxide emissions. What's interesting about this overall to me is that there's definitely a divergence of what is the accepted narrative from what is actually a robust scientific discourse. So for instance, whenever I publish a video having to do with climate change, I get this little blurb here from climate change. It says, the United Nations, climate change refers to long-term shifts in temperature and weather patterns mainly caused by human activities, especially the burning of fossil fuels. And so that's the whole power of the United Nations kind of just entering in the scientific discussion. It's essentially a logical fallacy known as the appeal to authority, I would argue. And so whatever I have to say about climate change, and now granted I'm not a climate scientist, so that's fine, but I am a scientist and I'm engaging in scientific discourse. And whenever we have a conversation, the United Nations needs to step in and tell us that climate change is mainly caused by human activities. And it might be the case. It's just that every now and then something like this comes out where it's not obvious what the role of human-caused climate change is versus something else. So let's take a look at the actual research paper. This was published in the Journal of Science Advances in November 24th, 2021. And the title is Rapid Atlantification Along the Fram Strait at the Beginning of the 20th Century. And Atlantification is a word which means, in reference to North Atlantic ice covering, the switch from primarily icy or Arctic type ice covering to ocean environment, or otherwise known as ocean ice loss. So the abstract says, the recent expansion of Atlantic waters into the Arctic Ocean represents undisputable evidence of the rapid changes occurring in this region. Understanding the past variability of this Atlantification is thus crucial in providing a longer perspective on the modern Arctic changes. Here, we reconstruct the history of Atlantification along the eastern Fram Strait during the past 800 years, using precisely dated paleoceanographic records based on organic biomarkers and benthic foraminiferal data. Our results show rapid changes in water mass properties that commenced in the early 20th century, several decades before the documented Atlantification by instrumental records. Comparison with regional records suggests a poleward expansion of subtropical waters, so the subtropical waters are actually starting to move up towards the poles, since the end of the Little Ice Age, in response to rapid hydrographic reorganization in the North Atlantic. In other words, there's a change in the pattern of ocean currents, which is likely to have a strong role in this. And this is as we're coming out of the Little Ice Age, which was in Europe in, I believe, the 18th and 19th century primarily. Ocean currents are changing in response to this warming period, which according to climate scientists is not due to human activity. And so therefore this warming in the Arctic and this loss of sea ice has a lot more to do with, arguably, these changing ocean currents, at least in this early stage. So basically what they did is they took samples of ocean sediment and then analyzed the lipid content as well as the mineral content of those samples in order to learn something about what the environment was when those sediments settled. So since the sediments are layered down sequentially, so in a certain period of time you have sediment falling down and settling, and then as time goes on you have more sediment falling. If you analyze the content of the sediment at different layers, it should give you a sense of what was going on at specific time points. They say that our records can thus provide evidence at 5 to 10 year resolution of the oceanographic changes that occurred throughout the coldest phase of the Little Ice Age and during the following warm period. They say on the basis of this precise chronology, we combine our results with other local climate records to provide an integrated understanding of Atlantification and resolve its timing. So I don't have a really good sense of whether or not this is a reliable way to kind of reconstruct the past, but it does seem to be probably as good as most measurements that you're going to get in the past anyway. Nowadays we have satellite imaging and we can get temperatures in real time all across the globe, but we obviously didn't have that in 1900. And so this is kind of the best that we could do in terms of reconstructing historical records before a certain point. What's interesting is when doing this analysis, they also looked at the changes in ocean currents due to exiting the Little Ice Age. And what they say is controversy still remains on the relative impact of natural versus anthropogenic forcing on the North Atlantic system. In other words, they're saying that what's going on when it comes to polar ice cap melting, it's not really clear what the relative impact of human activities is versus just these natural processes. However, it seems likely that the slowdown of a key ocean current during the early 20th century has been caused primarily by increased export of Arctic sea ice and freshwater in the northeast Atlantic following the end of the Little Ice Age. Farther east, our results from the Fram Strait reveal an opposite scenario characterized by rapid sea ice loss and rapid Atlantification of water masses. Currently, the latest historical climate experiments fail to reproduce this post-Little Ice Age Atlantification documented in our reconstructions. These findings highlight a potentially important model and data discrepancy that begs for improved historical and pre-industrial simulations with better constraints on the freshwater budget of the Arctic and North Atlantic Oceans. They say that resolving these modeling issues will be crucial to improve the accuracy of projected Atlantification in response to future Arctic warming. In other words, as I was saying sort of in the beginning of the video, the fact that our current models don't explain the fact that we had this rapid ice loss earlier than expected means that our future projections of what's going to happen in terms of ice loss in the future drastically need to be updated. Now, I do want to be clear that this is not really a slam dunk on climate science. This is not saying that, therefore, the greenhouse gas effect isn't real, therefore we're off the hook and climate change is not a problem. But I do think it's an important thing from a perspective of nuance. I think that collectively and as a society, we should be interested in doing science to get to the bottom of things, that we should be trying to be as accurate as possible. However, nuance is really difficult to do when it comes to public discourse. For instance, it's probably likely that some percentage of people watching this video are going to walk away with the conclusion that climate change is not real, or man-made climate change is not real. That's not what I'm saying, but it is important to say that the narrative that we've been handed up to this point may not be entirely correct when it comes to the loss of Arctic sea ice. And that is comforting to some extent. It's nice to know that when it comes to the polar bear losing its habitat, we're not 100% to blame. And what's really interesting is if you look at atmospheric carbon dioxide, here we're looking at a graph from 1960 to 2021, you can see that atmospheric carbon dioxide is rising very rapidly from 320 parts per million to 420 parts per million. So that's something like a 34% increase in 60 years. That's a big deal. And it's also important to note that if you look at carbon dioxide over 800,000 years, you get a little bit of a more nuanced, but maybe even scarier perspective. And so what we're looking at here is, as I said, carbon dioxide over 800,000 years. And by the way, I think it's important to note that most biologists who are familiar with this literature put the human race in its modern biological format to be somewhere around 200,000 years. So when we're talking about 800,000 years, we're talking about a period which is much longer than the existence of anatomically modern humans. And you can see that the carbon dioxide rises and falls. It tends to rise. The highest previous concentration was 300 parts per million. And then you see this dotted line here shows an almost instantaneous acceleration when we're looking at timescales this large anyway, like the last 100 years is just a tiny blip. You can see that we've very rapidly risen to 412.5 parts per million. So we understand how a greenhouse gas works, and I don't want to in any way minimize the fact that we are, environmentally speaking, in uncharted territory. And I almost think that this should be the main argument. We shouldn't really be talking about specific global warming outcomes. Like, we shouldn't really be talking about we have to stop global temperatures rising by 1.5 or 2.5 degrees C or something like that, because I don't think we actually know what's going to happen. And this research, I actually love this research for this reason, because I've been saying this for a while. We should not be focused on forward modeling and simulation. We should be looking at things from the standpoint of the precautionary principle, which is that we should be cautious when we're in uncharted territory, when potential outcomes are unknown. Basically, the main argument, the central argument around stopping climate change should be, look, we have succeeded in significantly altering the chemical composition of the atmosphere as a species. We don't know what's going to happen. It could be absolutely calamitous. Or it might not be a big deal, but do you really want to take that risk? We only have one planet. I think that should be the central premise of climate change messaging. Because actually, it's kind of embarrassing for people like the United Nations, because right now when you have this new research, it kind of undermines their central message. If we say that Arctic sea ice loss, it's not possible to really decouple the effect of just the natural effect of leaving the little ice age from our sort of supercharged CO2 emissions in the last 100 years, because the sea ice loss actually started way earlier than we were anticipating, then that kind of defeats the narrative. But the reality is, even without these forward projections of Arctic sea loss or blaming it all on us, the projections are really scary, because we're just, chemically speaking, in uncharted territory when it comes to atmospheric science. Because these CO2 levels are significantly higher than anything we've seen in the last 800,000 years. That should be worrying enough without having to sort of blame every last detail of modern climate change on anthropogenic greenhouse gas emissions. It's more nuanced than that. Generally speaking, I will say that it's very understandable that we would attribute clear signs of global warming on CO2 levels, because as you can see from this chart, this is from NOAA.gov, you can see that we have CO2 levels over the last 800,000 years with temperature, and you can see that CO2 is in dark blue and temperature is in light blue. That CO2 and temperature follow very closely the same trend. Another chart that I think underscores the fact that there needs to be some more nuance in how we're understanding things like the impact of anthropogenic greenhouse gas emissions versus sort of this more natural process of ocean currents changing following the little ice age is actually this chart here from sealevel.info that says atmospheric carbon dioxide, CO2, and methane, CH4 levels, 1800 to the present. And what's interesting is you can see that at 1800, we have the CO2 levels, according to ice core samples, are at 283 parts per million, and methane is at 0.74 parts per million in 1800. And you can see that there is definitely some rising up to 1900, but it's not really anything very dramatic. And it's certainly not an excessive deviation from, we'll say, the more historical levels that we saw before. We're getting, I guess this is getting towards 300 parts per million, so according to our 800,000 year history, this is pretty high, but it's not crazy high. And we can see this is 1900, that by this time, according to this new research, there's already significant ocean sea ice loss at this point. Now, after this, we see from 1900 to 2000 and getting to 220, we see that carbon dioxide levels are absolutely just taking off like crazy. And so it would be understandable, like let's say if it was around 1977, for instance, where carbon dioxide levels were already rocketing past the 800,000 year records, of 300 parts per million, they're up to like 377 parts, 350 parts per million, something like that. And if this is when the sea ice loss started or got really serious, then it would be understandable. It would be very easy to attribute pretty much all of it to human impact. But if the ice loss is happening around here like 1900, then it's not as clear a story. It seems hard to believe that this level of CO2 wouldn't do something to what's going on in terms of Arctic sea ice loss, but it's obvious that not all of it can be attributed to human activities. Well, anyway, I hope that you're walking away from this video with a sense that this stuff is nuanced. And I do hope that as a community, we can be people who want to get to the bottom of things, even if it doesn't fit our preferred narrative. And in addition to that, my hope is that we can rely less on forward modeling and simulation, which in my opinion, and I am biased because I am an experimental scientist, not a modeling and simulation person, I think that we have had an over-reliance on predicting the future. I don't think we need to predict the future. I think it's enough to say that we are already in uncharted territory and we should be very cautious about that fact. Well, thanks so much for watching. I hope you enjoyed this video or found it useful in some way. If you did, please go ahead and like and subscribe, and I hope you'll join me again in the future soon. Bye.